Salerno, September 1943. On the southern coast of Italy, sea mist from the Mediterranean mixed with the smell of gunpowder and burning oil. The sound of artillery shells rained down on the wet sand as American soldiers scattered in search of cover. In 20 minutes, 47 men fell. There was no artillery support, no response from the fleet offshore. The only thing heard on the frequency was the static hiss of white noise. Offshore artillery operators waited in vain for a request signal. Meanwhile, the soldiers on shore were unable to transmit orders. "Radio's dead again," Sergeant Rawlins exclaimed, slamming his hand against the SCR 536 unit on his shoulder, its antenna trembling in the hot wind. According to the Signal Corps Field Report, 1943, the entire communications system at Salerno collapsed within the first 17 minutes of the landing. The cause seemed simple. The SCR 536's AM signal was disrupted by salty moisture and ionized currents from naval guns. But behind that was a fundamental design limitation. Each SCR 536 weighed 5 pounds, had an effective range of only 300 yards, and over 60% of the radios failed under combat conditions. The AM frequency was distorted by electromagnetic interference, making it impossible for units to connect with artillery or naval fire support. On the battlefield, that distance was the line between life and death. In a documentary filmed by the Army Pictorial Service, Private Turner is seen leaning against a shell crater, eyes sunken, staring into the radio. He recalled after the war, "I screamed into the mic, 'Fire! Fire now!' But all that came back was silence. When the radio waves died, I knew my buddies had no chance left." From that point on, Salerno became a symbol of the price of silence. According to the after-action report, Fifth Army, throughout the campaign, average casualty rates were more than 30% higher than expected due to mistimed artillery support. By the time of Anzio, 1944, the same problem returned on a larger scale. Over 4 months of fighting, 7,000 soldiers were killed, trapped between enemy and friendly artillery. The Allied Communications Command report clearly states, 18% of tactical failures were attributed to communication breakdowns. Commanding officers called it the soundless front, a front line without a voice. Every unit knew that before the guns fired, the first thing to die was the signal. In a meeting room in Washington in 1941, 2 years before those numbers became reality, one man had already issued a warning. Lieutenant Colonel Rumbo, a communications specialist with the Signal Corps, slammed his hand on the table during a presentation to the National Defense Committee. "There's no handheld radio tech that goes past 2 miles, and anyone who tries will just be digging more graves." That statement was recorded verbatim in the meeting minutes from the 18th of July 1941, archived at Signal Corps Archives, Fort Monmouth. In an era when FM frequency was still considered academic play, that declaration was nearly gospel. But war is always the enemy of limits. When maps are burned and orders lost in smoke, people begin to ask, was technology really the problem, or had we simply refused to step beyond the line? That question spread across factories and labs from Chicago to New Jersey. In cramped rooms under dim fluorescent lights, at desks covered in copper wire and vacuum tubes, a group of young engineers began to think differently. According to the Motorola Company memo, 1940, engineer Daniel E. Noble, then just 34 years old, scribbled a note in the margin, "If we swap AM for FM, we don't need more power, we need less noise." That idea directly violated military contract terms, which only permitted the production of AM devices. But Noble knew that sticking to the 2-mile limit would mean thousands more dying in silence. On winter nights in 1940 at the Galvin Manufacturing plant in Chicago, the clanging of metal and the smell of ozone from soldered wires filled the workshop. Engineers stayed late past office hours, turning off the lights on the ground floor and keeping only one small upstairs room lit. Henrik Magnuski, Marion Bond, Lloyd Morris, and Bill Vogel stood around a wooden table, soldering copper wires so thin a breath could snap them. A red bulb blinked on the wall, signaling the test transmission. At a distance of 5 miles, They heard a voice respond through the mic. Clear as a bell. They looked at each other, silent, then smiled. In that moment, they had just broken the rules. Under the contract, any testing outside the AM band was prohibited, but they knew that if it could save a soldier dying because he couldn't call for fire, breaking that rule was worth it. And in that silence, a new idea began to live. According to the U.S. Signal Corps Technical Summary 1946, that very invention would later reduce frontline casualties by an average of 36% when deployed at scale. But in 1940, no one knew those numbers. There were only drops of sweat, a few burning light bulbs, and a group of people who believed radio signals shouldn't stop at 2 miles. From Salerno to Anzio, from silence to the first signal, humanity's war with its own limitations began that way. And in the stillness between 2 artillery blasts, history waited for those who dared to hear each other again. In the fall of 1940, Chicago was still shrouded in industrial smoke, with chimneys along Cicero Avenue, spewing out thick vapor like leaden mist. In the red brick building of Galvin Manufacturing, a young engineer named Daniel E. Noble, 34 years old, a recent graduate of the University of Connecticut, was inspecting each component of the AM radio he had been assigned to design for the military. On paper, his task was clear. Improve the stability of the SCR 536 by optimizing the antenna and power supply. But in Noble's mind, the plan was different. He didn't want to patch flaws, he wanted a complete overhaul. According to Galvin's internal records from 1940, Noble submitted an 8-page memo in which one line was underlined in red, use FM instead of AM. That proposal directly violated a clause in the military contract, which explicitly required AM signals for compatibility. The legal department warned that this idea could cost the company the entire contract with the Signal Corps. Noble remained silent, then said, "If they want a radio for wartime, they need to be able to hear in a real war." In the evening, after the official shift ended at 5:30 p.m., light still spilled from the windows of the 3rd floor. Inside, 5 people gathered around a wooden table covered with blueprints and copper coils. Noble led the team. With him were Henryk Magnuski, a Polish engineer who had worked with FM circuits in Warsaw, Marion Bond, a quartz crystal specialist, Lloyd Morris, in charge of power systems, and Bill Vogel, a wave measurement expert. They called their group by a simple code name, Project 103. With no budget and no access to the main lab's equipment, they scavenged broken parts, spare vacuum tubes from the civilian production line. Magnuski later recalled in a 1957 interview, "We used copper wire taken from old telephones, and the radio casing was made from empty ammunition boxes. Amid the smell of soda smoke and the whirring of industrial fans, they began to rewrite the limits of radio waves." The first problem was the oscillator crystal. Marion Bond selected 40 samples from over 300 crystals stored in Infantry, based on their thermal stability. Each crystal was mounted in a test circuit and measured for error down to the thousandth of a second. When one of them held steady at 42.6 MHz for 3 hours, Bond simply smiled and wrote on the wall, "Candidate 12, stable." That frequency would later become the foundation for the SCR 300 series. Vogel and Morris focused on the amplification section. They used 18 vacuum tubes, arranged in 2 amplification stages and 1 modulation stage. The entire device weighed 42 pounds, about the size of 3 50-caliber ammo cans. "It was ugly," Vogel recalled at a 1962 seminar, "but the voice on the other end was so clear we thought we were in the same room." On the 24th of October 1940, they decided to test it outdoors. The site was a vacant lot behind the factory, where abandoned rail cars lay rusting. Magnuski brought the transmitter, while Bond and Vogel drove farther away, mile by mile. When the signal meter held steady at 5 miles, Vogel keyed the mic and said succinctly, "Galvin, do you copy?" Noble's voice came back almost instantly, clear and interference-free. "Copy loud and clear." Then silence. The entire group understood. They had just done what the military said was impossible. According to Motorola historical notes, 1946, that signal was recorded on magnetic tape in the test room. It was the first known recording of mobile FM communication reaching 5 miles in a natural environment. When played back, a faint chuckle could be heard at the end, a strange sound in an era where every invention was shackled by regulation. But that success came with risk. Noble knew that if the experiment was reported to Signal Command, the whole group could be investigated for modifying contractual configuration. In a private letter to Magnuski, he wrote, "They want radios to survive bombs, yet they fear every idea that steps beyond the licensing line. If this is a crime, I accept it." That sentence became the group's unspoken manifesto. They kept refining the circuit, reducing the weight by replacing 6 AC7 vacuum tubes with 6 SK7 models, saving 4 pounds without sacrificing power. They repositioned the antenna, switching from a straight pull-out type to a coiled wire, improving efficiency by 15%. Each change was logged in a 200-page notebook, every measurement marked in handwritten notes: gain plus 2.1 decibels, noise negative 6%, range 5.4 miles. After the war, those entries were preserved in the Motorola archives as the Field Engineering Bible. According to the U.S. War Department memo 1943, at the same time, the Signal Corps still maintained that FM is unsuitable for field use. When that report was released, Noble just laughed. He told the team, "We're not building radios for offices. We're building for those dying in silence." That sentence echoed through the factory, making people believe they were doing the right thing, even though the hallway posters still read in bold letters, "Unauthorized modifications prohibited." Late at night, when the lights were out on the lower floors, Noble sat alone, listening again to the test recording. The sound came through FM waves, clean, sharp, unbroken. For a moment he thought he heard a voice from a distant battlefield, a soldier calling back to an artillery unit. "Fire on coordinates." Then the signal clipped. Noble looked out the window, the factory smoke fading under the Chicago moonlight, and he whispered, "Someday they'll understand why we did this." Oh? According to Galvin's internal statistics, by the end of 1940, Project 103 had completed 3 fully functional prototypes, each capable of running more than 11 continuous hours without circuit failure. None of them received a reward, nor were they allowed to publish the results. They had built a truly working illegal radio, and when those numbers lay still in the company's safe, they knew the hardest part hadn't even begun. Because what they had touched was not just a technical breakthrough, it was a statement. Technology cannot be locked down by fear. And in an old factory in the heart of Chicago, 5 quiet workers had just planted the first seed of a radio revolution that would go on to save thousands of lives. On the morning of the 12th of November, 1940, the sky over New Jersey was low and overcast, with fog curling around the rows of pines at the gates of Fort Monmouth. At the Signal Corps testing base, 15 officers stood in line, heavy coats soaked with cold mist. In the center of the yard, a 42-pound radio unit sat on a wooden table, its long antenna rising like a spear. Daniel E. Noble stood silent, hands clasped behind his back, eyes fixed on the flickering power meter. Beside him was Henrik Magnuski, in charge of frequency control, while Marion Bond bent down to adjust the crystal stabilizer. In the gallery, Signal Corps officers exchanged skeptical glances. According to the Fort Monmouth test log, 1940, the test was classified as a restricted demonstration. The device, provisionally named Portable FM Transceiver Type X by the Galvin team, was subject to harsh conditions, humid weather and sea breeze, which easily interfered with signals, an ideal setup to prove FM's effectiveness. At exactly 10:20 a.m., Noble flipped the switch. A sharp click echoed, and the indicator light turned orange. On the other side of the forest, 6 miles away, Vogel held the receiver. Into the mic, his voice came through. "Galvin Control, do you read?" The group held its breath. 1 second passed. 2 seconds. Then a voice broke through the speaker, clear and crisp. "Reading you 5 by 5. The sound echoed through the room, cutting through the wind and whispering doubts. A young officer muttered, "Impossible." No static, no background noise. Just a voice, as clear as if it were right next to them. According to the test transcript, background noise measured below -40 decibels, and signal range remained stable for 32 minutes. For the first time in history, a handheld device had transmitted FM voice across a 6-mile forested distance. When the demonstration ended, Major Stoner, representing the Signal Corps Engineering Division, stepped forward. He was a conservative figure, known for his strict stance on out-of-contract proposals. "Production cost is triple, weight is double, and it violates licensing terms," he said, enunciating each word with a hint of anger. "You think the army can rely on an unapproved device?" The room fell quiet. Noble looked him in the eye and replied, "Sir, we don't think we hear, and that's what a soldier on the front line needs most." According to the internal meeting notes at Fort Monmouth, the debate lasted more than 90 minutes. Stoner insisted FM was unsuitable for the battlefield due to its complex components and high power consumption. Bond countered that a properly phased FM amplifier circuit consumed 15% less power than AM. Magnuski projected an interference chart. The AM frequency band was a chaotic black blur, while the FM band showed a single, fine, sharp line. "If a whisper can cut through gunfire, that's worth the cost," he said. The remark left a few senior officers exchanging silent glances. Lieutenant Colonel Rumbo, who had once declared that no handheld radio technology exceeds 2 miles, sat in the middle row, eyes fixed on the test results. He was the embodiment of regulation, the overseer of all military communications projects. When Stoner wrapped up his final objection, Rumbo stood. The room went completely still. He looked toward the Galvin team and asked a question that stunned everyone. "If you're a lieutenant out there, caught between enemy shells, would you choose a 300-yard radio or one that reaches 3 miles? No one answered. Only the sound of wind slipping through the metal window frame. Rumbo gave a slight nod and turned to the clerk. "Record this. Project 103. Proposal to proceed to military field testing. According to the Signal Corps Decision Memo 1941, that was the moment he broke the very rule he had created. The silence in that room was heavier than any applause. After the test, the Galvin team was invited to stay at Fort Monmouth for 3 more days to present technical details. They dismantled the device, pointed out each circuit and vacuum tube, and explained how FM signals rejected interference by relying on frequency variation rather than amplitude. Rumbo listened without speaking, occasionally asking, "If it gets submerged, will it still work?" Magnuski replied, "We're developing an insulating coating. Give me 3 months." He took notes but didn't object. According to an internal Motorola report from 1941, shortly after the meeting, Noble received a telegram from Galvin headquarters. "Proceed with FM design. Military evaluation pending." That short sentence officially turned the illegal into a military-supervised project. On the 15th of January 1941, the Signal Command signed a provisional approval for the project, designating it SCR-300. At the signing, Rumbo quietly said to Noble, "You know how much heat I'll take for this." Noble smiled. "If it means a soldier can call home, I think that's a fair trade." According to the Department of Defense Oral History, 1952, Rumbo later admitted, "That was the only time I broke the rules and I never regretted it." Outside Fort Monmouth, snow had begun to fall, blanketing the base entrance in white. The group of engineers left the building, walking slowly across the frozen ground. They said nothing, only looked toward the test antenna still standing in the yard, its shadow stretching across the snow. In that silence, they knew they had crossed the boundary of an era. According to U.S. Signal Corps statistics, after approval, the first SCR-300 prototype was built within 43 days, marking the shift from AM to FM in the military communications system. From the moment Noble flipped that switch, the course of wartime communications changed direction. And when the reports were sent back to Washington, there was only a single note at the bottom. This equipment operates beyond contractual limits but meets battlefield needs. A short, cold line, yet inside it was a declaration to the world that some rules exist only until the day someone dares to break them. In August 1942, the jungles of Guadalcanal were damp and muddy, the air thick with the smell of gunpowder and decaying leaves. Carlson's raiders had just completed a raid on a Japanese artillery position along the Tanaru River. As the sun set, enemy artillery began to counterattack. Captain Ernest Peters, communications officer, pulled from his backpack a new device with a green-painted casing and a long antenna rising above the grass. On the body of the machine was the label SCR 300. He flipped the switch, a faint static buzz sounded, and a voice from offshore responded almost instantly. "This is USS Helena, ready for coordinates." Peters checked his stopwatch. 40 seconds after sending the request, the first barrage from the fleet landed on the forest's edge, wiping out the Japanese machine gun nest. The after-action report stated, "No casualties. Communication time under 1 minute." Oh. According to the U.S. Marine Corps after-action report, 1942, this was the first time in the Pacific that artillery was adjusted accurately using long-range FM communication. Previously, support requests typically took 8–10 minutes via hand signals or AM radio, with coordinate errors reaching up to 30%. A sergeant recalled, "I saw the first shell land less than 10 yards from the enemy position. No one believed we could direct artillery that fast." The equipment was heavy but stable, functioning for 5 hours in 95% humidity, with no interference and no interruptions. For them, it was something that changed the odds of survival. 3 years later, on the 6th of June 1944, just as the sun rose over the English Channel, the beaches of Normandy were already stained with steel. Amid the howling wind and roaring artillery, Captain Milton Skip Gray of the 1st Infantry Division clutched his SCR 300 radio to his chest as he waded through the freezing water. Bullets from German ships whistled overhead, but he kept the antenna upright. Reaching the shore, he opened the mic cover and shouted, "Target grid 23, B, fire for effect." Far offshore, the USS Texas received the order and turned its guns. 83 German positions were destroyed in 11 hours. From Omaha Beach, the smoke rose like a giant curtain covering the entire front line. According to the 9th Air Force Combat Report, on D-Day, units equipped with the SCR 300 achieved an 85% success rate in artillery missions, while those using AM radios reached only 52%. Skip Gray wrote in his journal, "I never thought we could talk this clearly, like we were standing side by side. The naval guns sounded like they were just waiting for my order." At the bottom of the page, he added a line, "This box saved men, not just battles." After the Normandy campaign ended, the Signal Corps held a meeting in Cherbourg to gather feedback. Dozens of frontline officers reported the same conclusion. FM signals cut through interference, were stable, and reduced artillery call time to under 2 minutes. Lieutenant Colonel Rumbo, now promoted, quietly read the figures, his hand trembling slightly. He remembered that morning in 1940 at Fort Monmouth when he had said, 2 miles is the limit. Now, the report clearly stated, average range 3–5 miles, effective under combat stress. He set the folder down and smiled. According to the captured German Communications Review, 1945, General Alfred Jodl, head of operations for the Wehrmacht, admitted during interrogation at Nuremberg, American communications far surpassed what German engineers thought possible. They spoke amidst artillery fire as if in a conference room. His words echoed in the cold courtroom under harsh lights, making the interpreters pause their pens for a few seconds. The transcript of the interrogation preserved that bitter tone, a confession from a nation once confident that engineering was its ultimate weapon. That same year, in Luxembourg, the Signal Corps held a small exhibition for Allied units. On the display table, among charred radios, Skip Gray's SCR-300 was placed at the center, its casing still coated with sand from the Normandy shore. When the microphone was reconnected, they played the original recording, Target Grid 23, B, Fire, and the sound of the responding artillery. That noise filled the room, causing many to stand still. A British officer quietly remarked, "That's the sound of justice by frequency." After the war, Skip Gray returned to Ohio and became a military instructor. In a 1948 interview with American Radio Journal, he recalled, "Back then, forward observers like me had only a 30% chance of surviving a campaign. But with this radio, we could hear, we could see, and we lived to tell it." He placed his hand on the worn SCR-300, his voice lowering. "It kept me alive, and that's enough." According to the War Department Statistical Review, 1,946, the data confirmed what Gray said. The survival rate of forward observers rose from 32% to 68%. Artillery response time dropped by nearly 80%, and casualty rates due to coordinate errors were nearly zero. Those dry numbers were the living proof of a technology once labeled illegal. From the jungles of Guadalcanal to the sands of Normandy, the voices that traveled across FM frequencies had bridged both ends of the battlefield. Soldiers no longer shouted into the void. Artillery was no longer blind in the smoke. Every command, every copy that, became a lifeline for thousands. In a 1945 documentary screened in Washington, Noble sat in the back row, listening again to the first recording. When Skip Gray's voice rang out, "Fire for effect!" he gently closed his eyes, hand clenched slightly. It was the moment when every number, every circuit board, and copper wire of his became a real voice, a voice from the front line, and proof that innovation not only wins battles but saves lives in war. When the war eased and the guns fell silent, people began to look back, not with emotion, but with numbers. In rooms filled with charts and tables in Washington, the Signal Corps compiled data from hundreds of battlefield reports. Thick pages, black ink, packed with figures on survival rates, artillery response times, and signal interference levels. And it was there that officers first realized FM technology hadn't just changed how people communicated, it had changed the fate of thousands. According to the War Department Statistical Review, 1,946, during the period from 1,942 to 1,943, before the SCR-300 was deployed, standard AM radios painted a brutal picture. The average casualty rate for units using AM radios was 18.3%. The average time to call in artillery support was 115 minutes, and the mission success rate stood at 64%. These numbers weren't just cold data, they were the final breaths of platoons trapped when transmissions cut out mid-command. One captain noted in his report, "We kept calling, but the signal died before the shells came." When the SCR-300 was widely deployed from mid-1944, the entire tactical structure of the US military shifted. According to statistics from the Pentagon Signal Evaluation Committee, the casualty rate dropped to 11.7%. Artillery response time was cut to 1 to 2 minutes, and the mission success rate rose to 83%. In the Normandy campaign alone, over 2,400 missions were completed thanks to the SCR-300 maintaining stable communication. Those numbers forced the Department of Defense to re-evaluate its entire philosophy on the role of communication in warfare. In a summary sent to the Office of the Chief of Staff, someone wrote, "Communication speed is now a weapon." A short sentence, but one that captured a fundamental shift in military thinking. Transmission speed was no longer just a support tool, it had become a decisive weapon. According to the Joint Operations Review, 1,945 units with response times under 2 minutes had 42% higher survival rates than those using AM equipment. For every second the signal was faster, a life could be saved. At a review meeting in March 1946 at the Pentagon, Lieutenant Colonel Rumbo, now a technical advisor to the Signal Corps, stood to read the final report. His voice was low but clear. An estimated 17,000 lives were saved by switching from AM to FM. The room was silent, save for the sound of papers turning. An older officer spoke up. "We spent too many years thinking that innovation was a luxury. It's a responsibility." That statement was recorded in the meeting minutes and later became a reference in military technical academies. According to the Army Communications Analysis, 1,947, among more than 50,000 SCR-300 units produced, the failure rate was only 2.3%, mostly due to drained batteries or extreme environmental conditions. Each unit had an average durability of over 800 hours of continuous operation, 4 times the pre-war technical standard. Each figure was proof of the precision in design and the relentless standards of the Galvin engineering team. Cold charts lined the walls, yet within those numbers, one could still feel the breath of frontline soldiers, those who survived because the signal made it through. Daniel E. Noble was invited to present before the Military Scientific Council. He brought with him the original circuit diagrams of Project 103, now yellowed with age. When projecting the interference comparison graph between AM and FM, he said, "It all started with eliminating noise." In the hall, the projector's light illuminated his face, tired, but intensely bright. According to the meeting minutes, many officers stood to shake Noble's hand after his presentation. One said, "You saved more lives than an entire division of doctors." Back at home, engineers in the Motorola workshop read the report with quiet pride. One worker wrote a letter to Noble. "I wasn't at Normandy, but I know my hands touched something that helped them come home." Noble kept that letter for the rest of his life, tucked inside his 1,940 test notebook. It was proof that technology, when used right, could redefine the meaning of the word weapon. According to the Post-War Communications Survey, 1,948, FM's effectiveness soon spread to civilian use. Police, fire departments, and aviation began adopting the 40-48 MHz frequency, establishing a new global communication standard. People realized that what was once deemed illegal in a lab had become the foundation of public safety systems worldwide. When all the data was compiled, the final report, titled SCR-300, Tactical Performance and Human Impact, was delivered to President Truman. On the last page, a handwritten note by the secretary recorded his words during the briefing, "Technology justified itself when it saved lives." That quote was later engraved on a brass plaque at the Smithsonian Institution, just below Noble's original radio unit, as a reminder of the human value behind innovation. From the post-war perspective, the numbers were no longer just technical stats, they became proof of the power of belief and knowledge. The 18.3% casualty rate was replaced by 11.7%, the 115-minute delay was cut to 2 minutes, and 17,000 lives were saved from being lost in the hell of war. It wasn't a miracle, it was the result of the courage to push past the limit, and when Noble was asked what made him most proud, he answered simply that they heard each other. Because sometimes, victory doesn't come from the sound of gunfire, but from the moment people hear one another through the chaos. While gunfire echoed across Europe, in Chicago, other sounds filled the air, the hum of lathes, the pounding of hammers, the hiss of electrical tests. Since 1941, Daniel E. Noble's Galvin Manufacturing plant has been mass-producing communication equipment under the SCR-300 designation. Initially, the production line had only a few dozen workers, with a modest output of 150 units in the first year. But war gave them no time to pause. By mid-1943, production reached 1,200 units per month, and by December 1943, that number had surged to 3,500 units divided by month. By the time the war ended, nearly 50,000 units had been assembled, tested, and sent to the front lines. According to the Motorola War Production Report, 1,945, the Galvin plant operated 24 hours a day, divided into 3 continuous shifts. Low-hanging fluorescent lights cast a cold glow on faces smeared with oil and metal dust. On the conveyor belts, bare radio frames moved like a stream of steel blood. Each component had to pass 18 quality inspections by engineers. Each unit was tested continuously for 11 hours in a soundproof room where the temperature was maintained at 72 degrees Fahrenheit to simulate battlefield conditions. The average defect rate was under 2%, and most issues stemmed from the battery, the only part not manufactured by Galvin. The young women working here were called signal girls. They installed vacuum tubes, soldered copper wires thin as hair, and checked frequencies through headsets. A worker named Eleanor Davis, in a 1947 interview, said, "I didn't know where they used this machine, but every time I heard the click when it worked, I thought of a soldier hearing his buddy's voice again." That simple statement reflected the spirit of thousands quietly building the foundation of victory. Noble often walked through the workshops at night, notebook in hand. He didn't wear a suit like other executives, but always donned a thick canvas jacket, stained with soldering grease. "If this radio can carry a voice through bombs and fire, it's thanks to you," he told workers during one inspection. A young engineer recorded that moment in his journal. He looked at the machine as if it were a living creature with a soul. According to the War Production Board report, 1,944 to reach 3,500 units divided by month, Galvin had to open 2 additional workshops and restructure the entire workflow. The line was divided into 27 stages, from tube installation to final frequency check. For every 116 units divided by day completed, Noble would write that number on a large whiteboard in the office. Beneath the figures, he added, "Each unit is a company's lifeline." That number wasn't a slogan. On the front lines, each company typically used exactly one SCR 300 to direct artillery and call for medics. When a unit failed, dozens of people could lose contact forever. In the plant's acoustic testing chamber, technicians jokingly called it the whisper room because everyone communicated only through gestures to avoid signal interference. Each radio carried a handwritten label, signed by the final inspector. One engineer, Marion Bond, who had worked with Noble on Project 103, maintained a habit of scribbling a small line in pencil. "Good luck, boys." After the war, many soldiers returned radios with that writing still intact, and Bond said, "I never thought they'd read that through the fire and smoke." The wartime pace turned everything into clockwork. Every hour that passed meant 5 more units completed. The night shift was the hardest, when the sound of freight trains outside mingled with the buzz of welding. Workers nodded off at tables, but when the signal whistle blew, they stood up and continued assembling the next coils. Many didn't know who Noble was, but they knew what they were making was helping someone out there survive another day. According to the Industrial Efficiency Review, 1,945, Galvin achieved 8 times the productivity initially projected by the Department of Defense. Producing one SCR 300 took an average of 16 labor hours, 40% lower than planned, thanks to the lean assembly line model Noble developed. Economists called it a homefront engineering marvel, on par with building Liberty ships in a matter of days. But behind the figures and reports were people. A machinist named Harris Coleman said that every time a shipment of radios was crated, they held a small ceremony. Everyone stood silent as Noble made the final signal test. When the words, "Copy that," came through the receiver, the entire workshop applauded. It was the moment they knew they had just sent off something that could carry a voice back from the edge of death. In 1945, when news of victory arrived, the entire plant paused for 10 minutes. No one spoke, but many cried. One female worker hung up a handmade sign. Our voices reached them. A photograph of that moment was later displayed at the Smithsonian Museum, next to the first SCR 300 ever built on that production line. According to the Pentagon's Signal Corps Division, by the end of 1945, over 97% of U.S. units in Europe and the Pacific were using FM equipment. That meant nearly every fire for effect command in the war's final battles passed through the hands of workers in Chicago. They never went to the battlefield, never carried a weapon, but each solder joint they made helped tens of thousands return home. In his 1951 memoir, Noble wrote, "Victory was not built by individual ideas, but by hands that never tired." That line is engraved on a bronze plaque at the entrance of the old factory. now Motorola headquarters, and whenever someone passes through, they can almost hear the echoes of those days, the hum of electricity, the clang of metal, and the voices that came through fire and smoke to tell the story of triumph. In the fall of 1945, the war had ended, but in the halls of Washington, applause still echoed for those who had forged victory through intellect. On the 15th of November 1945, the U.S. Department of Defense awarded the Medal for Merit to Daniel E. Noble, recognizing his contributions in developing the FM tactical communication system. Alongside him, the names once quietly working on Project 103, Henryk Magnuski, Marion Bond, Lloyd Morris, Bill Vogel, were also acknowledged in the commendation record. Noble stepped onto the stage to receive the medal, wearing a simple grey suit. His voice was deep and brief. Innovation was never about glory, it was about lives. In the hall, the lights reflected off the silver medal, gleaming like the first signal he had ever heard from the New Jersey forest in 1940. After the award ceremony, Noble was appointed Vice President of Engineering at Motorola, overseeing all military and civilian communication research projects. Over the next 2 decades, he registered 75 patents, including frequency modulation technology, mobile antenna designs, and noise filtering circuits. According to the Motorola Corporate Archives, 1965, many of his inventions remain foundational to modern radio systems. When a reporter asked what he was most proud of, Noble replied, "Not the number of patents, but the number of people who lived because of them." His technical legacy spread quickly. After the war, the 4048 MHz band was officially designated as the public service communication standard in the US. Police, firefighters, emergency medical teams, and even aviation systems adopted FM for its threefold improvement in stability and interference resistance compared to AM. According to the Federal Communications Commission report, 1948, average interference in public service communications dropped 82% after switching to FM, reducing average emergency response time from 7 minutes to 3 minutes. From that point on, FM became the common language of those who protect life. Other nations soon followed. The UK, France, and Canada integrated the technology into their fire and medical systems. By the early 1950s, Japan deployed FM for Tokyo's police force. A 1953 United Nations report concluded, "The post-war communication standard was born from a wartime necessity." From a project once deemed a contract violation, FM had become a global standard, connecting all branches of emergency response and modern communication. But the greater legacy was the ethical question Project 103 left behind. In a 1957 lecture at MIT, Nobel stood before hundreds of students and said, "Sometimes, to save lives, you have to break the rules." The hall fell silent. He recounted that morning at Fort Monmouth, when he flipped the test switch without formal authorization. "I knew it was wrong by contract, but right by conscience." That quote was recorded and archived in the MIT library as a declaration to post-war generations of engineers. According to the Journal of Military Ethics, 1962, scholars consider Noble's case a prime example of conflict between regulation and life. When bureaucratic processes become barriers to innovation, stepping beyond the line is sometimes the only way to preserve human value. A young Motorola engineer later wrote in his memoir, "We worked in the dark, but the light we switched on saved lives on the battlefield." In 1965, the first SCR-300 was exhibited at the Smithsonian Museum in the Inventions That Won the War section. Beside it was a brass plaque engraved with Noble's quote, "The most effective weapon was the one that let men hear each other through chaos." Visitors paused to read it, then stood silent. To them, the radio was not just a device, it was a symbol of courageous intellect. Magnuski, Noble's close collaborator, passed away in 1976, leaving behind a short note. "We didn't think we were changing the world, we just wanted the soldier to have a chance to call home." That line was printed on a memorial card in the exhibit. Bond, who once inspected each of the original crystals, continued to serve as an advisor at Motorola until retirement. In a final interview, she said, "I never thought a tiny piece of quartz could carry a voice across the ocean." According to the Pentagon Technical Heritage Review 1980, the legacy of the SCR-300 lies not only in its specifications, but in its philosophy. Technology must serve people before it serves institutions. After World War II, this idea directly influenced a series of defense projects from communication satellites to early warning radar systems. Noble was invited to advise NASA during the early Mercury program, where he proposed FM modulation principles to ensure stable links between Earth and low orbit. But despite widespread recognition, he remained characteristically humble. In a 1972 interview, when asked what had changed the course of communication, Noble answered, "I didn't change anything. I just listened when people said it couldn't be done." It was the same reply he had once given Major Stoner in 1940, when FM was still dismissed as science fiction. Looking back, the journey from Project 103 to Global FM was not just a story of engineering, it was proof of the power of belief. An idea once branded illegal ultimately saved 17,000 lives and paved the way for the entire modern communications world. From a small soldering workshop in Chicago to every emergency coordination center across the globe, that legacy lives on in every frequency, every signal, every voice. And when asked why he did it all, Noble once replied quietly, "Because silence kills." A simple answer. Enough to close an era, because amid the chaos of war, the most effective weapon wasn't a gun, it was the ability to make people hear each other. The numbers, the frequencies, and the hands that built them wrote one of the most vital chapters in the history of wartime engineering. From an idea once labeled illegal, FM became the foundation that allowed people to hear one another through chaos, saved over 17,000 lives, and shaped the entire future of communications. This is not just a story of science, but of courage, persistence, and the belief that true innovation always pushes past the edge. Thank you for watching. We're committed to bringing you the best content. Don't forget to subscribe for more remarkable battles ahead.